we are right on time, dear participants at the industry track. Now we can jump, and I'm so excited to introduce a great panel moderated by Ingrid Pristine from Cyprus on industrial production with AM standard and certification. Joining Ingrid is Victoria May from Protal UK and Lucia Cavallo from Bureau Vita. I would like to bring them to the stage with us here. Welcome, Lucia. You can put your camera. Yes, great. Upcoming is Victoria. You can put your mic and camera on. And last but not least is Ingrid. Ingrid, welcome, ladies. Let's just wait for Ingrid to jump with us. Okay, welcome, ladies, and thank you for giving us your time today and working hard for this panel and share it with our viewers today. I would like to give the floor to Ingrid Pristine, our moderator for industrial production with AM, discussing standard and certification. Thank you.
Thank you. Thank you. Thank you, Malaika. Thank you for the introduction. Thanks to everyone to be here and share our experience. Thanks, Victoria and Lucia, to be here, and we can start. I will just share my screen first. Just a second. You see my screen? No, are you able to see the big presentation? Yep. Yes, but I'm not able to show you. 2 seconds. Oh, okay, just a second. Okay, now fine. Do you see the presentation? Yes.
Sorry, Ingrid, can you put it in Diablo mode?
I don't, it's not. Are you seeing that? No. Oh, I'm sorry about that.
If you can send, yeah, just put it on presentation mode. Maybe go at the top and say present mode.
I did present mode, but it's not accepting. Oh, I'm sorry about this.
Okay, but like this one is, it just, we can see the writing.
Yes, I know.
I think because you just need to wear the right part of your screen when you go on present mode. It's showing your desktop rather than the presentation in presentation mode.
I know, and if I go this, you cannot see it, no? When I see this presentation myself. Oh.
Okay. If you can send it quickly to me, then I can share it from your side, my side.
Yes, I have sent it to you already.
Okay, I will share it from my side.
You should have it.
Is it on email?
Yes, it is on email, yes.
Okay, yes, I see it now.
Okay, great. Sorry about that.
No, don't worry. Okay, I'm just going to quickly download it. Oh, no, I can actually share it here. Let me just share screen, and then you can tell me how it looks like. Share. Okay. Can you see it on my screen?
It's charging
yes.
now. Yes.
Is it perfect?
Yes.
Just tell me when you need next slide, and then I will press next slide for you.
It's better. Thanks, Lucia. Thanks to everyone to be here, and thanks for Malaika to introduce ourselves. As you see, I will introduce myself. I'm in this market over 25 years. I mostly experience what I have is in the SLS printing sector with polymers. I got my first education at EOS, and after a while we saw that it's a very interesting market, and I found with my husband Cypress 2004 with the idea to be a service provider with polymers. A very soon time we found out that there is more than prototypes. Already 2006 we present the first finished parts, final part with surface preparation, with color. But on that stage, everyone was saying now SLS production will be just only for prototypes. But in the meanwhile, this topic changed a lot. And we are producing now end parts. The most interesting part in our company is the production of eyewear. We have many sectors, but the biggest sector that we have in the production is 3D printed eyewear in large quantities. We print mostly 60,000 frames per year. And on top, we do service providing for already printed parts. And in this sector, we are doing finishing over 120,000 pieces per year. So it's quite large amount. And this market is getting bigger and bigger. Yes, this is my part. I will go to the next one, to Victoria, please. Victoria, feel free, introduce yourself. And yes, hello, Victoria.
Hi everyone. Yeah, my name is Victoria May. I am a sales and marketing manager at ProTotal UK, formerly 3T. I've worked in the industry for around 10 years. I actually started off being a CAD engineer and working with the EOS machines back when ProTotal was 3T about 10 years ago. And yeah, I've worked in various roles in that last 10 years and ended up on the sales and marketing side. And at ProTotal, very similar experiences to Ingrid at Cypress. We're a polymer AM manufacturer, and we work across multiple different industries, from medical to aerospace to motorsport.
Thank you, Lucia. Victoria, now Lucia, it's your turn. Sorry.
Hello everyone. My name is Lucia Cavallo. I'm in charge of the industrial product certification at Bureau Veritas at global level. Since the beginning of my career, I have been involved in the standardization or certification process. Before as a representative for the mechanical manufacturer industry, and then I reached the Bureau Veritas already more than 10 years ago. Why I'm here today at Bureau Veritas, of course, we are required more and more to certify 3D printed components. And also, as we strongly believe that there is a scope for assessing technology and personnel and to verify and certify product. So this is the reason why we decide to develop a voluntary certification scheme to certify, so not only product, but also materials, processes, and personnel in case of using additive manufacturing. We also published a white paper explaining our methodology that is available for free on our website. We think that this will facilitate a wider adoption and a greater business value from additive manufacturing.
Great, Lucia. That's a nice point. We can go third. Could you turn the next slide, please? Then we can keep going on that. Yes. As you see, there's a lot of standards and certifications on the market that we have to fulfill. And I could jump to my question to you both. Maybe first to Lucia, could you name some standards and certifications, because you are really involved in the last years in this topic, so I think you are the right person for that.
So Each product needs to satisfy, when we intend to put a product on the market, of course, we need to satisfy the regulation of the market. If we speak about my sector, that is the industrial product certification, for instance, I can nominate the machinery directive for Europe, the low voltage electromechanical compatibility that are, for instance, the regulation that are applicable to AM machinery. And then speaking about the product, we can nominate the pressure equipment, the construction product, the interoperability for RAY, medical device, ATEX for equipment to be put in a potential explosive atmosphere. And then we have the same type of regulation covering the same product outside Europe. Of course, I can mention the GB standard for China. We work a lot on ASME, that is the regulation covering the pressure equipment in United States, or the S-Mark, that is a product certification from Australia. Of course, all these regulations and standards have been written considering classic manufacturing method. Therefore, it will be necessary to update regulation and write new standard. One thing that would like to highlight that we have already what we call a legislation framework. As for instance, I can make the example during what happened during the sanitary crisis. The European Commission published a document that was on the conformity assessment procedure for 3D printing and 3D printed product to be used in the medical context due to COVID-19. And this document clarifies that the legislative framework exists. For instance, machines are covered by machinery directive, and products are covered in this case by medical devices regulation. But in absence of dedicated standard, other standard may be used. In fact, one important thing of the new approach framework that we have in Europe is that all the regulations are written as a series of essential safety, health and safety requirements, and therefore the manufacturer is free to use whatever specification you need. So when manufacturer cannot rely on harmonized standard, as they do not exist yet, he can demonstrate by other means, for instance, experimental method or other technical specification, how the essential health and safety requirement could be satisfied.
Yes, thanks, Lucia. And how is your experience, Victoria, as a service provider? What standards you have to fulfill?
So as a service provider, our main sort of standards or certifications that we work to, we have mainly with ISO standards. So obviously our general manufacturing is under 9001. And we also have ISO 13485 and EN 9100. So we were actually the first bureau, I think it was maybe 10 or so years ago now, to have all three of those standards as an additive manufacturer. So that's our main experiences there, and they're obviously more based on the processing and how you actually manage your systems to be able to make parts for medical for ISO 13485 and aerospace parts for EN 9100. We also find that as a service provider, as there are so many standards and certifications either existing or being created, we tend to have customers come to us with quite specific needs, and we have in the past worked with our customers to actually create their own kind of internal specifications that they can work with. Because a lot of the time they're quite new to additive manufacturing, whereas we have 20 years experience in that. So in the past we have created specifications so that we can say to them, depending on the use case for the parts, we could be looking at how they should maybe qualify materials, or how they should qualify parts, or whether they need to be machine specific standards and things like that.
And adding to this, within additive manufacturing, how you define production versus prototype, how you see that as service provider?
So for us as a service provider, it's relatively clear for us. So a production component, how we define that, is just a component that actually has an end use. So it's going to be going into some real world cases versus a prototype, obviously, as the name suggests, is a prototype component that's not necessarily going to be used repeatedly. What that means, though, is that obviously production, usually people think that must mean, lots and lots of volumes, but actually it doesn't have to. So in terms of the sort of standards that might be applied for certain things, for example, in medical applications, we make production components that are used in surgical situations, and we produce them under 13485. But they may be, one-off products, because the whole kind of beauty of using additive manufacturing within the medical industry is obviously that it can be completely custom. So we may actually find we may make 20 components, but every single one of them is different, but we still class that as a production process that we need to, add a few more things than we might do for a standard prototype component.
Okay, and Lucia, what do you think about these low quantities? Do they justify the needs and costs for the qualification needed?
So, if we speak from our point of view as inspection board, of course, if the product is subject to what we call mandatory certification, then if it is a single unit or it is a huge series, there is anyway no choice, it has to be certified. But what we can say that the standard and regulation normally have been written also with the support of industry. It was my previous job, for instance. And normally the aspect of cost of certification are taken in consideration into regulation in the standard. One important information is that European Commission estimated the cost of certification, and it has been calculated as 0.5% of the final value of the product, including the internal cost of quality. So if we take the European directive, depending on or also other regulation, normally depending on risk category of the equipment, and also the fact that the equipment is manufactured only one single product or in series, there are different procedure of conformity assessment. So normally this has been taken in consideration. Of course, so this is for mandatory certification. If we speak about voluntary certification, then of course it's not so evident, and the value of the final product or the size of the production are really relevant to decide if go or non go versus a voluntary certification. Also, if sometimes voluntary certification can be imposed by the market, so also if it is not imposed by the regulation, so imposed by the client, for instance, or I would like also to highlight the added value of a certification for a product in the market.
I think it's my experience is if we start a certification at the beginning, it's a lot of time and cost, but after you have done once, then for the next projects you are prepared, and so these costs are not loose, so the next production will be already involved with a qualification. So can we jump to the next slide, Lucia, because I will present a sample of production, a really success story of production. In this case, our mostly experience, what we have with production is 3D printed eyewear. Last year, the company Baba, eyewear producer from Portugal, brought to the market a collection for the Japanese architect Kengo Kuma, with a collection for the Olympic Games together with Mamona. She's an Olympic winner, and the idea of this product, Kengo Kuma, came to us asking for sustainable production with material that are renewable materials, and everything printed because his ideas are not cannot be produced in other way. And they took the material PA11, material produced from castor oil, and for him was very important that at the beginning already starting producing or planting the beans has to be certified that there is no competition in the production with water, or that the people or the farmers get well down paid. And this should be really sustainable from the beginning to the end. So it means that when the customer doesn't want to have the eyewear anymore, that this eyewear has to be recycled, go back to a recycling process. And the nice is that this PA11, the company who produced the PA11, we came together and say, okay, we will be able to bring back the printed eyewear after the customer doesn't want to have anywhere and be really recycled. So we could convince him with this material that it's a strong material. PA11, it's really nice for, as you see in the slide, the structures are some places are the very brittle, but with PA11 we have a strong material with a strong UV stability. The colors are UV stable, and the post-processing, it was kind of difficult to do the tumbling of the PA11 because it's a strong material. But at the end of the day, we have a really nice product, and this is a sample that everything has to be covered. For example, for this was very important to have for each material that we're using for the production, the colors, the infiltration, everything has to have a Rich and Ross certificate, and every footprint has to be listed and fulfill all these expectives. So with this, I would really jump to the next question, maybe to Victoria. What are the key difference between components and approval of material process? So the approval from of the components versus the approval of manufacturing process, because I was talking about the approval of each components, but how about the manufacturing process too versus?
So in our experience, the approval of the manufacturing process is obviously very different to looking at part level approvals. So from a manufacturing point of view, again, it can be very different depending on industry. So some industries don't put too much emphasis on the machine you're using or necessarily how you're doing what you do with that, whereas other industries are really specific. So for instance, within the aerospace industry, we have instances where for them to qualify a part, they first obviously have to qualify how they're going to make it, and that can go down to a really granular level to where they actually approve making those parts on a very specific machine, and they can't move away from that once that approval's been done. So that's where it can sometimes incur costs in the future, because potentially, for instance, with an EOS machine, you may have qualified parts on a P760 and your service provider may stop having that machine and move on to a 770. All that qualification then needs to be done again in certain industries like aerospace. So, you know, even down to the material type and the age of that machine can be quite important, and they can't kind of digress from that, because obviously for aerospace parts, they're pretty safety critical. If you get something wrong, you've potentially got lives on the line. In terms of the standards we work to, obviously the ISO standards, as I mentioned earlier, are really more specific to our sort of management systems and how we process our parts. So we have to create, for instance, for ISO 13485 for medical, we have a methodology of how we process an order for a medical requirement. So from quote all the way to when it leaves the building, we have a very specific process for that, and our customers will come in usually and verify that. So having the standard itself is obviously a great start, and shows people that we can manufacture parts to that standard. But obviously many medical providers are going to want to come and actually do their own audits as well. So they have their own things that they want to check that manufacturers are actually doing before they will be able to commit to you making parts for them. So our medical process, we have a completely different powder stream. So we don't mix our powders for medical work versus any of the other work that we do. We limit the recycles on that as well. So within polymer laser sintering powder-based materials, we recycle that a lot, but within the medical stream, we cut that down so that we can really have a really tight control on our materials as per our customer requirements. So the way we process those materials, that's not dictated by 13485, but that's customer requirements that we have to do. So there's a balance between the standards and also what the customers actually want for us to be able to manufacture parts. Then when it comes down to actual component approval, it can again vary quite a lot. So again, within aerospace, you tend to find that they're going to want to know a lot more about the mechanical properties of that material. So we'll have orders where we make the same parts repeatedly for years, but we always have to build various test bars with those parts. And when the parts come out of the build, we have to, do tensile tests, etc., on those parts, so on the bars, to verify that the parts can then carry on being processed. So there's quite a lot of differences, and then obviously, standard sort of inspections that need to be done to make sure that parts comply with drawings, and then also verifying certain ways of how we post-process the parts. So it might be in terms of colouring. We've got different colouring for automotive parts than we do for non-automotive parts based on the properties of that die and how it performs within a kind of car environment. So those are the kind of key differences between manufacturing process and parts. They're quite kind of different things to look at.
Thanks. Very, very interesting. It's exactly the same experience we have. I will jump to the next question, Lucia, to you. Maybe you want to put your slide. Exactly. Thank you. So my question, how can we satisfy the industrial product regulations in case of additive manufacturing production?
Yes, of course. So as defined before, the first step to be followed when we decide to design a new product is, and to be put a product that should be put in a certain market, is to identify what is the regulation that is applicable. Once the regulation has been identified, it is necessary to study the requirements and the conformity assessment procedures, and to organize from the design to production and control checks to be done, all in order to satisfy what are the technical requirements. If they are not supporting standard, I'm calling supporting as they are not of harmonized standard. Now in the UK, we have what they call design standard or other standard supporting regulation outside Europe. We can use other standard. For instance, I can mention the ISO ISTM 52901 that contain a general principle for additive manufacturing. So then some of the existing standard related to manufacturing and use of a specific product are applicable whatever the type of machine or process used, so it can be used. It is important to choose the correct raw material, of course, and this is the importance to have also raw material certified. It is important to apply appropriate post processes that should be also validated. But finally, if we need some other additional specification, we can use it, or experimental methods can be used with the assistance, for instance, of a third party, or also in case we can also contact a national competent authority to verify if what we are proposing can be acceptable. I can list the main step to obtain what we call a type certification. That is, of course, the identification applicable regulation, what we call design review, that is the FEM validation, the basic material characterization, and if the raw material has been already certified, we can perform some tests on the specimens. Product process assessment, including post-process operation, and as final, the product validation test on what it is, the final product. And then finally, a type approval certificate can be issued if a certification body has been involved in the process. Can I ask to Malika to go to my slide, so slide 4? Yes. So this is a case study that I would like to present that is very significant as it is a certification or lifting accessory that is a product that is covered actually by the machinery directive. And this is made so in fiber filler polymer, so nylon mixed with the chopped carbon fiber instead of of course the original component that has been made by steel. The AM technology used was the fusion deposition modeling. Here we follow the step. So identification, applicable regulation, machinery directive, design review, FEM model validation has been done. Basic material characterization, and in particular have been done tests on specimen using ISO standards that normally are applicable to steel, but of course our experts have validated the part of the standard that could be used. So in particular, traction strength in accordance with the ISO 527 part 4, compression strength in accordance with ISO 604, 3-point bending strength in accordance with ISO 178. Then production process assessment, of course, and product validation step on the product. In this case, according to machinery directive, it is necessary to carry out load cycle phases. Therefore, finally, our component has been, as a lifting accessory, has been certified according to machinery directive, with the big advantages that the weight is now 2 kilo instead of 10 kilo before. The working load has been multiplied by 5. And of course, as for all products with additive manufacturer, it is cheaper and faster and can be printed only when needed on site.
Thanks, Lucia. It's a really nice sample to see why additive manufacturing can move a lot in the production. And Victoria, you as a service provider, getting in touch with these different kind of regulations, how can certification bodies work better with service providers to ensure standards are in line with industry norms and abilities? How you see that?
So yeah, as a service provider, it's quite tricky. So sometimes you can find out about a kind of AM specific standard to a certain industry just when someone from that industry is actually asking you for some parts, and they just happen to say, can this, ASTM this or whatever the standard might be. So that can be quite sort of limiting in terms of there's so many, and I think one of the questions that have popped up is this probably will help to answer that. There are so many bodies, there are so many standards, and there's so many people looking at additive manufacturing standards. It can be a little bit of a minefield, and also quite difficult sometimes to actually interpret the standards themselves. Obviously, they're written in very specific ways that the people who write the standards makes perfect sense, but the people who have to interpret them to be able to put it against their manufacturing processes, it can be quite tricky. So some of the things I think generally is they just need to start working together more and much more openly. I think that's a real key thing. So sometimes you'll find that certain standards might get written. So previous experience on metal additive manufacturing, where it can be a bit more stringent in terms of material qualification. We were working with an oil and gas project, and the customer came out with these certifications and standards that have literally just been written for additive manufacturing. And it was all about material qualification, but it was so heavy on upfront qualification of that material that it ended up pricing out probably nearly every project that would have ever started, because there was so much testing at the beginning. And sometimes standards are obviously written with certain companies. You know, there was a heat treatment company, for instance, involved in this particular one, and so lo and behold, the standard said that, you know, everything needed to be hipped after it had been printed, which is certainly not the case with DMLS printing. So I think there's a lot that needs to happen there, where standards tend to be written with whatever things used to be done in mind, and that we can't look at things like that, because that's not how we work in additive manufacturing. It's very different and it's very new, and you can't compare, you know, qualifying billet material to qualifying powders. It's not the same. So I think certainly being more open and working more closely together with sort of research facilities and people that are creating the standards like ASTM and things like that would be a real big help. As well as that, you know, we've had here in the past, when we have to work to say an ISO standard, we have had the bodies come in for training. So they've actually come to us and given us, you know, a day or two's training on the whole standard, because as I said, they can be quite hard to interpret if, you know, that's not your daily job. Obviously, we have a quality team here who that is their daily job. But even then, there's a lot to take on sometimes, and having training days where people, you know, the people that have written them can actually go through things, and you can properly understand how to interpret what you need to do to make it fit with your process is certainly very important. We did a very small project that involves ASTM. We're looking at whether there should be some standard to how much you can recycle nylon powders. Everyone does that differently now. I'm sure Ingrid's company does it very different to how ProTotal do it, and everywhere else. And I think, again, that's got some value to it in putting some kind of standard on that sort of thing. But it also, you have to be very careful, because it could end up causing huge cost increases for certain companies, or it could, you know, determine quality either in a positive way or in a negative way, depending on what that standard is and who that standard's written with. So yeah, I think there's lots of ways that they just need to communicate much more and work together, so that the bureaus like ourselves can actually understand them and know, you know, which ones are relevant. Because sometimes you have standards that are written for the same things but by different people. Which one's the right one? You know, there's not that kind of one mainstream standard at the moment for AM.
Yeah, and that's why I asked Lucia, for example, are the standards, if they are fast enough, if you want to involve the standards in the production on the product, are these standards fast enough or not?
But actually, there are a lot of standardization working groups that are working hard to cover the lack of standard in the additive manufacturing. For instance, our experts are engaged in many different working groups, starting from ISO TC 261 additive manufacturing, all the joint working group related. I would like also to mention the CEN-TC 54 working group 11, that is quite difficult job, as they are working in the pressure equipment and components that are fabricated with additive manufacturing method that are really completely different of what we know with pressure equipment and welding and so on. But the question to the answer, they are fast enough? I think is no. I think is normally is no. As a standardization process, we know that are quite complicated. There are always so many different interests. Sometimes they are in conflict. Also, if in the last year a lot of progress has been done in improvement and simplification of standardization process, I think that the AM technologies are going so fast that standardization cannot be online in line with this progress. This is the reason why we need to find other specification, use the help of technical assistance, and so on.
Thanks for all you answering all these very interesting questions. I saw that in the QM question box we have some questions from Carol, and I don't know, maybe you take a look and we decide which one to answer, because we're still having time on that. I have with the highest interest, do you certify 3D printed parts or assembly for food-related materials? How is your experience? Do you have this? We have many times this question. How it's in your situation, Lucia, with the certification?
Honestly, I'm not aware yet, but I needed to come back to my colleagues, as we are really a big group. So I'm based at the head office. We have a center of excellence that is based in Italy, but then we have qualified personnel, so they could work in Germany, Spain, United States, and China. So I need to verify. For my information, I don't think it is the case yet.
Yeah. Well,
we hope that it will come, of course.
Yes. It is important. You know, I think the printing materials, they are certified. Mm-hmm. But the main problem is the post-processing, like if you're putting coatings or colors, for example, we are the color experts, and all the colors that we use are for wearables, but they are not certified for food purposes. We are sure that there are some colors that we can use for it, but we have to certify the part on that, and it makes very expensive situation, because each color has their own property, and so you have to certify color by color and then part by part, and depending how the coloring goes into the part, and etc. So there are many things, and there are some certain high expenses for that, but I think it is possible, but it's not ready yet. And how is your experience in that direction, Victoria?
So we work with a few companies that are in the food industry. Generally, as you said, Ingrid, like the material itself is technically a food grade material. So we work with a majority of the time with PA12, which is a food grade material. But again, it comes down to what we said earlier, that there's a difference between part qualification, process qualification, material qualification. So the material ticks the box, but is the way we process it suitable for a food part? Not necessarily. Or certainly we don't do that as standard. So in our experience, we basically tell our customers, like, the material, yes, that ticks that box. How we process it currently doesn't. And then it's up to them to decide if they would like to go down that route. And generally it's for prototyping, so it's not too much of a problem. Obviously the material itself sometimes is too porous to actually be used in food itself, but we do a lot of parts for food production lines, so it doesn't touch the food, but it's used on the lines, and then it's up to our customers to qualify that. And obviously anything they need from us, we can help them with. But yeah, there's that issue again with which part of the process is actually qualified to be able to do something.
Well, my experience, for example, for medical devices that are being used during surgeries, and they are colored and they are coated, or they are just chemical smooth, we know they do the certifications by their own, because they are responsible for that, and they do pass. So we know that the things that we're using for that are materials that really are able to use on those places, and they can be certified. But as a service provider, it's for us very difficult, because we're getting all the needs, and we cannot fulfill everything. So as a service provider, you cannot pay the cost for that. So that's why I think that we need certain regulations on the market that has, that we can come together and try to make regulations on that, and different colors and materials and coatings, that everyone can use that. Not every service provider to get to that point. I think we need some kind of different place of that. We have some more questions on the panel. I don't know, Lucia or Victoria, do you see the questions? Is any of them that you would like to answer?
So there's one that Carol's asked about aerospace parts. So yeah, so for aerospace, as I said, we tend to, the qualification generally from our customers is dictated that tensile bars and things like that have to be printed with the parts in order for them to then be tested and then processed through. So your question on how would you set up the same process for spare parts? Again, you'd have to, it comes down to customer requirements, but if that's a requirement, then it would have to essentially force the price of spare parts up, because you'd have to incorporate the fact that you have to do that material test each time. But the caveat to that is we have other customers within the same markets even that don't require necessarily to have tensile bars made every time. It might be every few batches, and providing you're doing the production parts, which we are for most of those customers anyway, we build that data and can show our kind of consistency with mechanical properties and things like that, enough that then when there's a spare part coming into the system, you wouldn't need to do the same qualification again. But it's very much down to what customers are after, and we just work with people to make sure that whatever qualification is needed for material or process, we kind of work together to get it right, and try as much as possible, obviously, to keep the costs down, because one thing that standards and qualification and certifications do is tend to make things more expensive.
Okay. Wonderful. Thank you, ladies. Thank you, Ingrid, Lucia, Victoria, for this interactive session and attending to all the questions. Our time is up for this panel. I would like to thank you for all the preparation and your time and sharing insights. I would like as well to encourage our participants to reach out to you via LinkedIn, if they have any other question, and as well join you at the networking session now and discuss further any topic or any related things to the panel discussion that happened just now. Thank you again. I appreciate it.